Okay, let's take a look at geometric sequences. A sequence is geometric if the ratio of consecutive terms are the same. So if you remember an arithmetic sequence, the difference was the same. We had what we call a common difference. Now we're going to have a common ratio, and a ratio is just where you take a division or a fraction of two numbers. So the sequence A1, A2, A3, A4 is geometric if there's a number R such that put A2 divided by A1 or A3 divided by A2 or A4 divided by A3, and we get R, that common ratio. And we got to make sure that that R is never zero. All right, that R is called, again, the common ratio. So the examples 1 through 4, we're going to look at 3 that are geometric and 1 that is not. So the sequence whose nth term is 2 to the n is geometric, right? The first 5 terms. So we plug in, we get 2 to the 1, 2 to the 2, 2 to the third, 2 to the fourth, 2 to the fifth. Or 2 to the first is 2, 4, 8, 16, and 32. And again, take any term, divide it by the term before it, and we get 2. So 8 over 4 is 2. Understand another way of looking at it is what do you do from one term to the next term? You multiply by 2. That's the common ratio. That's fine. Sequence whose nth term is 4 times 3 to the n is geometric. Write the first 5 terms. So again, it's 4 times 3 to the 1, 4 times 3 squared, 4 times 3 cubed, 4 times 3 to the fourth, and 4 times 3 to the fifth. Or, if we write them out, 3 to the first is 3 times 4 gives us 12. 3 squared is 9 times 4 is 36. 3 cubed is 27 times 4 is 108. 3 to the fourth is 81 times 4 is 324. And 3 to the fifth would be 243 times 4 is 972. All right, take a look at C. The sequence whose nth term is negative 1/3 to the n is geometric. Write the first 5 terms and determine the common difference. By the way, real quick, if I go back up here, determine the common ratio. This should say ratio here. This should say ratio here. And I should find those. So in this case here, R is 2. Here, R is 3. We're tripling every time, multiplying by 3. Let's take a look at C. So if I take negative 1/3 to the first, to the second, to the third, to the fourth, and to the fifth, we will get negative 1/3. We will get positive 1/9. We will get negative 1/27, positive 1/81, and negative 1 over 243 with a common ratio of negative 1/3. Show the sequence 2n squared is not geometric. So if I plug in 1 and I plug in 2 and I plug in 3, we get 1 squared is 1 times 2 is 2, 2 squared is 4 times 2 is 8, 3 squared is 9 times 2 is 18. And if I put 8 over 2, that gives me a ratio of 4. But if I put 18 over 8, I don't care what it is. I just care that it is not 4. So it is not geometric. All right, let's go ahead and move on to the next page of the notes. All right, so what happens when we multiply by the same thing over and over and over again is we get an exponential function. And so exponential functions are always written as a base to a variable exponent. It's a fixed or constant base with a variable exponent times an a value or an initial value. So the nth term of this geometric sequence has the form an equals a1 times r to the n minus 1, where r is the common ratio. So if we just kind of take a look at these terms right down here, the first term is a1. The second term is a1 times the common ratio. The next term is going to be this times r, again, the common ratio. So I get a1r squared. And if I multiply that by r, I get a1r cubed. And so our first, second, third, fourth, fifth, and on term looks like this. So to get any term, it's always going to be the first term times the common ratio whose power is 1 less than the term that we are on. So let's take a look at some examples. So the first 5 terms of the geometric sequence, whose term is 3, first term is 3, and common ratio is 2. So I'm starting with 3, and our ratio is 2, so it doubles every time. So we get 6, then 12, then 24, and then 48. Now, if I was to write the equation, it would be any term is going to be the first term, which is 3, times the common ratio to the n minus 1. So that if, for example, I needed the 20th term, it would be 3 times 2 to the 19th power, whatever that would come out to be. All right, so if I need the 15th term, well, I'm not going to list them all out. That's going to take a while, especially if the first term is 20 and this common ratio is not a very easy number to work with. So we're going to go ahead and start with an is the first term, which is 20, times 1.05, the common ratio, to the n minus 1. So that if I want the 15th term, it's 20 times 1.05 to the 14th power. And if we multiply that out, I get 39.60. That's not a 0. There we go. Example 4, find the formula for the nth term of the following sequence and then tell us what the 9th term is. So our A1 is 5 and our common ratio is that it triples every time, so the ratio is 3. So AN is A1 times R to the n minus 1. So if I want the 9th term, it's 5 times 3 to the 9 minus 1, or 8, and that comes out to be 32,805. I'm going to go ahead and cut it here just to keep the notes at a nice length.